Example 1. Find the center, vertices, and foci of the ellipse. Graph each one by hand. Okay, so it looks like we have 3 examples here. I'm going to do the first one, and let's see, example 1A and example 1C. So that means example 1B is all on your own. You got it? So let's label center, vertex 1, vertex 2, center versus foci, focus 1, focus 2. These are all the things we have to do in addition to graphing. Looks like the center is going to be at 0, 0 because none of these have an add or minus any variable. So, and I'm going to plot as we go along. Okay. Now, as you can see, this doesn't have a denominator, so I can technically put it over 1. Since y squared is over 16, that's a bigger number. 16 is bigger than 1. So what's happening is that it's going to position vertically. Okay? Vertically position. Well, I know that is always the bigger number is always a squared. So a squared equals 16. So a equals square root of both sides, a equals to 4. Technically plus or minus 4, but remember a must be bigger than b and both of them must be positive since we're talking about distance. I'm going to go up 4 units. 1, 2, 3, 4. 1, 2, 3, 4. So that's your a. This is going to be vertex 1 and this is going to be vertex 2. Yes, you can switch v1 and v2. It doesn't really matter. So order pairs would go 0, 4, 0, negative 4. Now I know b squared is the other denominator, which is 1. So b equals 1. I'm going to go to the right 1 unit, to the left 1 unit, and make my minor points. So connect the dots. So graphing is probably the easiest out of all of these. Okay. Now I need to find c in order for me to find the foci. So remember, the equation is always a squared equals b squared plus c squared. I know a squared is 1. I'm sorry, a squared is 16. I lied. A squared is 16. B squared is 1 equals c squared. Minus 1 to both sides. So 15 equals c squared. C equals square root of 15, which I can't write right now. There they go. Technically, again, plus or minus. The c is going to be a distance, so I don't need to do plus or minus, okay? So, I know the foci will be along the y-axis, since that's where the vertices are. So that means only the y-coordinate needs to change from the center. So the x-coordinates of focus 1 and focus 2 are maintaining the same thing. So I'm going to go 0 plus or minus square root of 15. If you want foci to be on the top, let's just say square root of 15 is about the square root of 9, square root of 16. So this is 3, this is 4. So closer to 4. Okay, so closer to 4. So somewhere here, how about that? So we can say that's focus 1. And that could be focus 2. Now, if you want focus 1 to be on the top, then you just need to add square root of 15. So that's a positive square root of 15. And then this will be a negative square root of 15. Yes, you can swap them. I don't care if focus 1's in the bottom and then focus 2 in the top. It doesn't matter as long as you have it labeled. All right. And I think we found everything and we graph everything out. It's going to highlight all these answers. Like I said, I'm going to do example 1A. And example 1C, and then I'm going to leave example 1B all on your own. All right, 1C, looks like you need to do a little bit of completing the squares. Let's put all the x's first together. X squared plus 8x plus a blank space. And then this is 3y squared minus 6y plus a blank space equals to 5. Now, before you can fill in your blank, we have to factor out your leading coefficient. All right, I took out a 4, so this is x squared plus 2x left plus a blank. I took out a 3 on the y, so this is y squared minus 2y plus a blank. Let's fill in the blank spots, okay? Okay, here we go. If I can get a pen. All right. Half of that, so half of 2 is 1. 1 squared is 1. What you added on the left side, we would now go and add on the right, except that this one gets multiplied by 4. So that gets multiplied by 4. Over here, half of 2 is going to be 1. 1 squared is 1. Same thing, except again, this thing gets multiplied by 3. So we are going to multiply the right side by 3 as well. Then from here, let's factor. Okay, so x plus 1 quantity squared, drop down your 3. Y minus 1 quantity squared equals 5 plus 4 is 9. 9 plus 3 is 12. Now, mind you, you can't have a leading coefficient here. I'm sorry, it's not the fact you can't have a leading coefficient, but we have to make this into, the equation has to equal to 1. So you have to divide each and every term here by 12 to make the right side equals to 1. If you do that, we can reduce that. X plus 1 quantity squared over 3 plus y minus 1 quantity squared over 4 equals to 1. So that's an equation that we could use to find all of our information. Okay, we can start with the center. Let's use a pen. Center is going to be -1, 1. So let's plot it. Let me go and make some tick marks if that's okay with you. Okay. I'm gonna go 1, 2, 3, 1, 2, 3, 1, 2, 3. All right. Center is -1, up 1. So that's my center. Let's see how this is positioned. What you want to do is look at the bigger number. It's with the y, so we know it's going to be vertically positioned. So if it's vertically positioned, I know a square equals 4. So that means a equals a distance of 2 units. So that means I'm going to go up 2 to make my vertex 1 and down 2 to make my vertex 2. Okay. Then that means this dude over here, that's your b squared. So b squared equals 3. That means b is rad 3. And rad 3 is the distance in between 1 and 2. So I don't care if you go anywhere in between 1 and 2 distance. So, oops, and I meant to put that across of the center. Here we go, right there. So that will give us the minor points to draw out our ellipse. And this one looks a little bit circular than the other ones. There you go. Now let's find C for us, so that way we can find the foci. So it's going to be a squared equals b squared plus c squared. A squared is 4, b squared is 3 plus c squared. So that means c equals 1. Okay, c equals 1, so that's going to go up 1 to make focus 1 and down 1 to make focus 2. All right, I have the center. I'll box that up. I now need to go find focus 1, focus 2. I'm sorry, vertex 1, vertex 2, focus 1, and focus 2. All right, let's fill it in. All right. So the center, the x value will not change for the center or the foci. So I'm going to write the -1 back on all of them. All right. Since it is vertically positioned, only the y values are changing. To get vertex 1, I'm going to add a value. A is 2. So 1 plus 2 is now 3. And technically, you can count. Okay. Same thing, now I'm going to subtract 2. So 1 subtract 2 is now -1. And that should totally match up with your point, vertex 2 on the graph. For your foci, we would take the y coordinate and add the c value. Since they're both 1, when we add them together, we'll get 2 for focus 1. And then the y coordinate of the center is 1 minus c value is going to be 0. So those are the two ordered pair for our foci. Example 2. Find an equation for each ellipse, then graph the equation by hand. They give us the vertices at positive 3 and negative 3, 0. So V2. Now you can put V1 over here, V2 over here. It doesn't really matter to me, okay? All right, so we got the vertices. So that means since the vertices is on the x-axis, we know this is horizontally positioned. If it's horizontally positioned, then the x square should get the a square. Then that means the b square is left with the y. I know the center is right in the middle between the two vertices, so we know the center is at 0, 0. They gave us c equals 2. We know a is 3. So a is always half distance between vertex 1 and vertex 2, or the distance from the center to one of the vertices. So that means a squared is 9. If c equals 2, well, I guess I can go straight to c squared equals 4. So let's use Pythagorean theorem for the ellipse. A squared equals b squared plus c squared. A squared is 9 equals b squared. C squared is 4. That means b squared is 5. That is enough for us to write our equation. A squared is 9, put 9 in there. And then y squared over b squared, which is 5, equals 1. That is perfect for our equation, okay? Now we need to figure out where square root of 5 is. Square root of 5 is perfectly in between square root of 4 and square root of 9. This is 2 and this is 3. So closer to 2. So 2 and some change, just like that. Make your ellipse. Try your best to make a nice ellipse. It doesn't always happen for me, but I'm still trying. All right, so that's my ellipse. And I said graphing in the ellipse unit is a lot easier than anything else. And again, I already took my time earlier to make all the tick marks for all 3 examples here, just to save us some time in the recording. So let's go and plot focus 0, 4. 1, 2, 3, 4. So here we go. Here's F1. And then the vertices are 0, 8. Do I have 8 tick marks? If not, I need to add one more. So do 8 right there and negative 8 right there. So 0. So vertex 1, vertex 2. Okay, so that means the foci number 2 is 4 units down from the origin. Just like that. Okay, now we know the center is at 0, 0 because the center is right in the middle of the 2 vertices, or right in the middle of 2 foci. So if I know the center, which is right here, I know C equals 4 units, but in c squared is 16. I know A is 8 units, so a squared equals 64. Let's find B, because you need B to find the 2 point for the minor axis, okay? So a squared equals b squared plus c squared. 64 equals b squared plus 16. Subtract 16 from both sides. So b squared equals 48. Now 48, simplify that. I don't need to simplify to write my equation, but I do need to simplify to plot, okay? Let's write the equation first. Center is at 0, 0. So x squared over something plus y squared over something equals 1. Since the vertices are on the y-axis, this is going to be vertically positioned. So that means the a square is going to go under the y square. So 64 goes here. 48 goes here. Again, I don't need to simplify that to write my equation. Now I need to figure out where 49 is so I can plot my b minor points. So 48 is here. Next perfect number is 49. And the previous number is 36. So that's 6, 7. So closer to 7. Okay, so I'm going to go a little bit past 7 units. 1, 2, 3, 4, 5, 6, 7. So slightly over here. Not exactly to scale, so don't hold me up. So it's almost near a circle, because if you think about it, the two vertices only go up to 8, and the minus already like slightly, well, that's an ugly one. Let's make that a little bit better. And the minor axis goes slightly a little bit past 7, so it's pretty close to a circle. All right. Let's go do the last one, example dos. All right, centers 1, 2, 1, 2. So center, check. Focus is 1, 4. Focus 1. If you know focus 1, because you added 2 units from the center, you can subtract 2 units to go to focus number 2. Focus 2, just like that. So we got focus. So that means we know C is always from the center to one of the foci. C is 2 units, okay? So C squared equals 4. And it says containing the point 2, 2. So let's go plot 2, 2. 2, 2 is right there. Okay, so since that is directly to the right side of the center, we know that has to be one of the minor points. So if I know that's a minor point and it's 1 unit to the right of the center, the other minor point would be 1 unit to the left of the center. So that means I know B is 1. So B squared is still 1. That is enough information for us to find A value. So A will get us the points for the vertices, okay? So A squared equals B squared plus C squared. So A squared equals 1 plus 4. So A squared equals 5. All right, that is definitely enough for us to write our standard form. Now, okay, so where do we put the A squared? Under the y minus k squared or under the x minus h squared? Hopefully you said y minus k squared. That is dependent on how the ellipse is positioned. Since the foci is vertical, right? That means it's parallel to the y-axis. So that means the vertice will also be parallel to the y-axis. So because it's that, a squared goes here, because a squared is always bigger than b squared in an ellipse. So we have everything we need. H is 1, so minus 1 quantity squared over b squared is 1 plus y minus 2 from the center all over. Your a squared happens to be 5. And remember, this always equals 1. Box that up. Okay. Where is rad 5, right? Rad 5, because I'm trying to look for a value, is between rad 4 and rad 9, 2, 3, so closer to 2. So I'm going to go a little bit past 2 units from the center, just like that, and then a little bit past 2 units from the center downward to say vertex 1 and vertex 2. Just like that. And let's see, did we find everything that it asked? Sounds good. We're done. Hi guys, this recording it's for example 3 from section 10.3, okay, on the ellipse. All right, so example 3 says write an equation for the ellipse. So first we have to identify the major axis. The major axis is parallel to the y-axis, okay? What does that really mean? It means that I want to start with an equation of x minus h squared, okay, over something plus y minus k squared over something. It's either a squared or b squared, always equals to 1. How do you know which one gets the a squared? Remember, the a squared is always the bigger of the two, right? Because the major axis is parallel to the y-axis, this gets a squared here, and that means this gets b squared. So first you have to figure out what is the center and how much is a, and then you can figure out how much is b. Because we're just writing an equation, I don't really need c. Okay, so the center looks like it's right here. If I will count, this is 1, 2, 3, 4, 5, 6. So a, it's 6. That means a square is what? Oh, you know what? I just counted incorrectly. I completely forgot to, oopsie, forgot to count. Look at the tick mark on the side. So the major axis is still here, but this is 1, this is 2, this is 3, and this is 4, okay? So from the center, okay, so let's, what the center is. The center is -2, 1. I was going by the boxes, but that is incorrect because I forgot to look at the tick marks on the x and y axis. Okay, so the center is -2, 1. What that means is now I want to count the boxes up and down to see how many units is A and B. So from the center, this is 1, this is 2, and this is 3. So A is really 3. That means A squared is 9, okay? I can also count to get B from the center, 1 and 2. So that means B is 2. That means B squared is 4. So when you're writing an equation, it's that easy. You just need to know your A and B. So final answer is x minus a -2 squared all over. B squared is 4. Oopsie, there are my popped-ups. Okay. Plus y minus k. K happens to be 1 squared all over. A squared is 9. Always equals to 1. Well, 2 negatives over here, it will make it a positive. So that is my final answer. I'm going to box it up. And that is that easy. So recap, to find an equation of an ellipse, all you need is a squared, b squared, and the center. Example 4. The mean distance of Mars from the sun is 142 million miles. If the perihelion of Mars is 128.5 million miles, what is the aphelion? Write an equation for the orbit of Mars about the sun. So if you remember, we have this picture drawn at the very front of this unit, right? So we drew a picture and we say, hey, sun, hey, Mr. Golden Sun, please come out and play. That's what my kids would sing. Okay, so here's the sun somewhere over here, okay? Then we want to know we have to write an equation and we want to know what is aphelion. So aphelion, based on our definition, is the longer distance from the sun, okay? That means perihelion is the shorter distance from the sun. So this is where it is. Okay. And based on our instruction here, it says that the perihelion is 128.5 million miles. And in addition, it went on and it said, hey, the mean distance, it's 142 million miles. And based on the definition, oh my gosh, these pop-ups are driving me crazy. Based on the definition, the mean distance is from the center, okay, to the vertex, or one of the vertices. Okay, so this is your mean distance. So it says 142 million miles, okay? So to write an equation, we would start with the standard form, okay? I'm going to assume the center is at 0, 0. Center at 0, 0. Just like in just like in application of the bridges or the satellite or the or the searchlights, okay? You can move the vertex anywhere you want. In this case, you can move the center anywhere you want, but it's probably best and easiest for us if we start at the center 0, 0. This one, the major axis, is horizontal. That means it's along the x-axis. So what I'm going to do is I'm going to start with the standard form. So x minus h squared. Because it's horizontal, a squared, the larger value goes here, plus y minus k squared all over b squared equals 1. So all I need is to find what a squared is supposed to be and b squared is supposed to be, since I already know the center. The center is just going to be x squared because the h is 0, okay? So I know, okay, again, I know what the mean distance is. The mean distance is 142 million miles. That is the value of a. So this is the value of a. So to do a square, okay, I'm going to assume that this is all in million of miles, okay? A square, I'm going to square it. So 20,164 million miles. So that's a square. Now, I can totally try to find b, because that's what I need to write an equation of my line. And I'm going to go back to the equation of a square. It's always b squared plus c squared, okay? Well, I know what a squared is, right? A squared is 20,164 million miles. I'm going to leave the million alone for right now, because later I'll just put it back, equals, I need to know what b squared is so I can use my equation. Well, I know how to get to c, right? C is the focus. C is the distance from the center to focus. Well, the sun is one of the foci, okay? The sun is one of the foci. And if I know this whole mean distance is 142, so that means I can find c. C equals 142 millions, take away 128.5 million using my calculator, which I don't know where it is. Let's figure this out. C comes out to be 13.5 millions, okay? I will write the millions later, but right now that's what C is. Well, since I know C, I will now plug it back in here. B squared, unknown, okay, plus 13.5 squared. So now I will try to find b squared equals 20,164 million minus what's 13.5 squared. Let me punch it in my calculator. 13.5 squared is 182.25 million. So 182.25 millions. I will subtract those two. So 20,164, take away my answer. So b squared is 19981.75 million. So keep this in mind, we're in million of units here. So now that I have that, let's write the equation, okay? So x, oh my gosh, look at this, all the pop-ups. X, h is 0, so it's x squared. A squared is known, 20,164 in millions, plus y squared all over 19,981.75 millions, okay, equals 1. This is just the equation. Then it wants to know what is the aphelion. Aphelion is that longer distance, okay? So all I'm really going to do is I'm going to take 2 times the mean distance in terms of millions, take away my shorter distance, which is 128.5 millions, which is now going to give me 155.5 million miles is the aphelion. Okay, so this is really kind of putting back into, do you know what word means what in the orbital of Mars around the sun? And this is the end of our example.